review system is one of the inventory management systems we are going to talk about in our book. In continuous review system, we continuously review the inventory position. When the inventory position reaches a predetermined value, which is R, we order a fixed quantity Q. So, in continuous review position, in continuous review system, we review the IP, the inventory position. When it reaches R, we order fixed quantity Q. So, the parameters in the Q system are Q and R. Now we have to determine the parameters. First, the Q. Q can be determined by any technical constraints. For example, a truck load can determine the shipment quantity, or constraints such as the capacity of a machine. It can be quantity discount offered by the supplier in order to get a reduction in the price of the material. And in most economical systems, we can use the economic order quantity. As for the reorder point, as you can see from the figure again, R should cover the pipeline inventory that we have mentioned earlier. Pipeline is the inventory that is needed for the material to receive. The lead time is the time between ordering and receiving the order. So, the reorder point has to cover this pipeline inventory plus safety stock to protect against uncertainty in lead time and in demand during the protection interval. Because we are continuously reviewing the inventory position, so the probability of stock out before the lead time is very small. The period that we have to protect is L. Okay. Then, as a summary, the reorder point should cover the demand during lead time, which is the pipeline plus safety stock. The pipeline inventory, D, average demand multiplied by L plus safety stock. Safety stock is function of the uncertainty in demand and in lead time. So it's function of sigma of demand and sigma of lead time. So first we have to determine the probability distribution of demand during lead time to determine the safety stock. Let's assume here that we have average weekly demand of some item 75 with standard deviation 15. If the lead time is 3 weeks, then we have separate 3 weeks. We can say that the demand for any week is independent of the other. So the demand during the whole lead time is an independent variable, which is the summation of the 3 independent variables. The average of demand during lead time is simply, as you can remember for probability and statistics, if y equal x1 plus x2 plus x3, where they are independent from each other, the mean of y is the summation of the mean of x's. And the variance of y is the sigma of variances. Okay? So here, the average demand during lead time is 75 plus 75 plus 75, which is demand multiplied by L. And the variance of demand during lead time is 15 squared multiplied by 3. So standard deviation will be of demand during lead time will be sigma demand, sigma weekly demand multiplied by the square root of L. Then the standard demand during lead time, when the lead time is constant, will have a mean of D multiplied by L, which is the pipeline, and a standard deviation of sigma demand square root of L. Now, here I am plotting the demand during lead time, okay, probability distribution. The average is demand multiplied by lead time, and the sigma demand during lead time, okay? The probability that the demand during lead time will be less than the mean is 50%. The mean is the average demand during lead time, which is the pipeline. So I'm adding a safety stock. R equals average demand during lead time pipeline plus safety stock. This is R. The probability of not stocking out here, it's called the service level. So we have to determine R based on something called service level. Service level is the probability that you will go and you will find the product that you want. So if we say that we have a stock out rate of 5%, this means that there's a probability 5% that you will not find what you want, and this means also that we have 95% stock out. From the Z tables, if the area here is 95%, area means probability of not stocking out, or the service level, you can find the Z. Z multiplied by sigma demand during lead time, this is our safety stock, because R equal to the pipeline, which is the average, plus safety stock. It's the distance between the pipeline and R. From this figure, we can say, in this example, the service level is 85%, okay? And the probability of the stock out is 1 minus 0.85, which is 0.15, 15%. Okay? Then, safety stock is Z, sigma demand during lead time. Sigma demand during lead time, as we mentioned, is sigma demand square root of N. The reorder point is the pipeline plus the safety stock. Let's take an example. Suppose that the average demand is 18 units per week with a standard deviation of 5 units. Lead time is constant at 2 weeks. Determine the safety stock and reorder point if management wants 90% service level. First, we have to go to the Z tables and pick Z for area of 90%. It will be 1.28. Safety stock is Z sigma demand during lead time, which is Z sigma demand square root of N. 1.28 multiplied by 5 multiplied by square root of 2, 9 units. And the reorder point is the pipeline, 18 multiplied by 2 plus 9, 45 units. Another example. Suppose that the demand during lead time is normally distributed with an average of 85. Here the demand is during lead time. He gave you the pipeline, not the weekly demand. So the average demand during lead time is 85, and the standard deviation of demand during lead time is 40. It's given. Find the safety stock and reorder point. Safety stock, Z sigma demand during lead time, which is already given as 40. It will be 66 units. And the reorder point is the demand during lead time, which is already given, 85 plus 66. The difference between this example and the previous example, they gave us the demand, the weekly demand. And you have to calculate the average demand during lead time and its standard deviation. Here it is already given straightforward. Find the safety stock and reorder point for 100% service level. If you go to the Z table, you can find that at 100% service level, Z is approximately 3.5. So the safety stock, 3.5 multiplied by the sigma, which is 40. And the average by simple substitution will be 225. Now, in the previous examples, we have discussed how to find R when the demand is variable but the lead time is constant. Now there is another situation. We can find the reorder point for variable demand and variable lead time. Again, the safety stock will remain the same, Z sigma demand during lead time. But the difference is in calculating the sigma demand during lead time, because here we have variability in lead time and variability in demand. R will be the same also, the pipeline plus the safety stock. The trick here is in calculating sigma demand during lead time will be square root of average lead time, sigma demand square, plus demand square, sigma lead time square. This is the trick. Everything remains the same, only the variability of lead time have to be added. Okay, let's take another example. The Office Supply Shop estimates that the average demand of popular pen is 12,000 pens per year. This is the average weekly demand. Okay, with standard deviation 3,000 pens. Now, also the lead time here is variable. The average lead time from the distributor is 5 weeks with a standard deviation of 2 weeks. We have variability in both demand and lead time. The current inventory policy calls for replenishment orders of 156,000 pens. Replenishment orders means queue. They are using queue of 156,000 pens. If management wants 95 service level, what should be the reorder point? As repeat the givens, average demand 12,000 with standard deviation 3,000, average lead time 5 weeks with a standard deviation of 2 weeks. First, we have to calculate the standard deviation of demand during lead time. L sigma demand square plus D square sigma lead time square will be 24,919. Then the safety stock is Z sigma demand during lead time. Z for the 95 service level is 1.67 multiplied by the standard deviation will be 41,000 pens. And the reorder point D multiplied by L plus safety stock. Okay? Now to calculate the total cost for a continuous review system, as you have known previously, the total cost is the total inventory cost, holding cost, plus inventory ordering cost. We used to say that the holding cost only for the cycle inventory. Now we have to include the safety stock. Then the total cost will be the annual cycle holding cost for the cycle, inventory, which is Q over 2, plus the holding cost for the safety stock, plus the ordering cost. Then Q over 2 multiplied by H, this is the annual inventory holding cost for the cycle inventory, plus D over Q multiplied by S, total ordering cost. H multiplied by safety stock, which is Z sigma demand during lead time, annual holding cost for safety stock. Now let's take another example. The discount stores uses a continuous review system. One of the company's items have the following characteristics. Demand equal 10 units per week, assuming 52 weeks per year. Ordering or setup cost, $45 per order. Holding cost, $12 per unit per year. Lead time, 3 weeks. Standard deviation in weekly demand, 8 units. Here they didn't mention standard deviation of lead time, so we can assume it constant. Cycle inventory or cycle service level, 70%. First, we calculate the economic order quantity, which is square root of 2ds over h. Here, D has to be annual demand, so we have to convert the demand 10 units per week into annual, 520 units per year. And substituted in the equation, it will be 62 units. The desired safety stock. First, we have to calculate the sigma demand during lead time, sigma demand square root of L, 14 units. And the safety stock, Z sigma demand during lead time for 70% service level. From the Z tables, Z is 0.525. So the safety stock is 8 units. The reorder point is average demand during lead time plus safety stock. 3 multiplied by 10 plus 8, 38. The total cost is, from the equation, the annual ordering cost plus holding cost of both cycle inventory and safety stock. Simple substitution, $845. Now, for the same example, suppose that the current policy is 8, not the economic order quantity, and the reorder point is 150. What is the changes in service level? Oh, now reducing R from 150 to 38 will reduce the safety stock. Since R equal average demand during lead time plus safety stock, and average demand during lead time is still the same, 30. So safety stock is reduced to 100 and safety stock here, when you have R 150, safety stock will be 120. So the service level here is calculated. Safety stock equals Z segment demand during lead time. Okay, so Z equal 8.5. From that Z table, the maximum service level of 100 is at Z 3.5. So any Z larger than 3.5 will give you 100% service level. So reducing R from 150 to 38 will reduce service level from 100 to 70%. Okay, we have 30% reduction. Note, this is very important note, Z equal 3.5, we have 100% service level. So we can achieve 100% service level by putting only 49 units in safety stock. So we don't have to put 120. The difference here, 49 units in safety stock can give you the 100% service level. So why to add more safety stock and to put 120 units? So this is extra inventory without any reason. Okay? In this, we finish this lecture about the continuous review system. We have another video about the periodic control system. Thank you.